Good day, I'm Dr. T and welcome to my office. Today I'd like to talk a little bit about error. And last time I talked a little bit about error and how that it's not a mistake, it's not a lie, it's the inevitable imperfection of measurement. I'd like to talk a little bit more about how those come out and the two general types of error in the measurement space. So I'm not talking about hypothesis, type 1, type 2, but instead of how your actual measurement could have some error in it, could have some imperfection. So there's two basic scenarios. One is what we call random error, and this is generally somewhat preferred because it can be mathematically dealt with a whole lot easier. So random error is that every time you make a measurement, so let's say you take a measurement of an item 3 times, odds are you're not going to get exactly the same measurement. It's sometimes going to be just a little bit larger, just a little bit lower. There's not going to be a pattern to which times it's larger and which times it's lower. It's truly random. So if you do this enough, you can average the measurements and you can get a number that presumably is much closer to the true value than any one particular number you measured. And thus we can deal with it. The amount of spread, the distance between these various numbers is what we call precision. A high precision means it's a very tight spread. A poor precision or a low precision means it's a fairly large spread. They're not very close to the average, so they're kind of all over the place. We can use statistical methods like standard deviation to mathematically describe the precision and how close we are in that spread, although that's not something we usually do in first-year courses. That's a little bit more of an advanced technique, but definitely something that's on the table. Now, random error can be dealt with statistically. The other approach is systematic error, and this one is much more difficult to detect and deal with. So systematic error is when every time you measure something, it's off by the same amount in the same direction. So if you do it multiple times, you're going to have them all wrong in the same direction. And this is a bit of a problem because if you average them, it doesn't improve your data because you've included the error in all of your measurements and in the same direction. It never cancels. This is usually due to something wrong with your instrument, whatever tool you're using to do your measurements, although there are other scenarios where your accuracy is off. There are ways to address this. Generally speaking, your goal is to detect and fix, not really to statistically adjust out. And the way you do this is you use a standard, and the standard is a sample that you know what it is. So you have something that you're going to measure, and you have something like it that you know the true value. Now you measure both things. You assume, and at this point you are at assumptions, there's no perfect way because you don't know the true value of the thing you are measuring to start with, because why else would you measure it if you knew what that was? But you assume that whatever error is built into your standard is the same as your unknown sample. So if you always read a little large or a little low, then you will know that, hey, you're probably reading a little large or a little low. Ideally, what you're then going to do, if your true value is not lining up with your measured value, what we call accuracy, a high accuracy is how close they are. So high accuracy, they're spot on. Low accuracy, they're not. So if your accuracy is lacking in what you would like, traditionally the general best approach is to fix whatever's wrong with your system. Figure it out and fix it. Alternatively, you can, and in some cases you have to, figure out how things are going wrong and you backtrack. You figure out if you're always reading a few percentage points higher, so if it's maybe a 2% high, or maybe it's always a fixed number, maybe 5 units of whatever your unit is, high or low, and just add that in or multiply by an adjustment factor. Either approach is legitimate. Obviously, it depends on what you're doing. It would be best if you could just fix it, but sometimes it's just impossible to fix. You're always going to get a thing wrong, so you have to do some mathematics. But you have to understand what's going on to do those mathematics, whereas the precision, you just average it. And bada boom, bada bang, you've got this. So with that said, see you next time.